Next up, we have Tatu Aalto, who works at F-Secure, a senior software developer in test with Windows antivirus client team. Today he is asking, tests are talking, are you ready to listen? Welcome, Tatu.
Thank you. I actually work with F-Secure, but it's not your fault. When I submitted my talk, I was working with F-Secure, but then the company split and I ended in F-Secure, and there's still F-Secure. But I'm not here to talk to my company, and I'm not here to talk about the browser library itself, because there's a separate presentation for that for tomorrow with Rene and Kerkko. Where are you? We're going to talk about fancy cool features of that. But I'm here to talk about tests. And this is what you see in a normal robot framework report. It's nice and green, and it's saying everything is all right. You can go sleep. And this one is shouting, I have something to say. I failed. And that's also a good thing, because then there's something to investigate and look. And I like them both. Which one do you like? Do you like the green ones, the pass ones? Raise your hands if you like the pass ones. Yeah, perhaps 1/3, maybe a little bit less. Who likes the red ones? Almost the rest, like 90% perhaps. If you noticed, I raised my both hands. I like them both. They're saying, but they're saying different kind of things. And there's different value in what they both are saying. But before we go what they say, we talk about coverage. Many people already have talked about coverage. Coverage is the favorite topic. And what I don't like about coverage, that many people see it as a number. There's a red thing that people see it's an 85% coverage that's out of the browser library. And some people even report that for the high management. We have progress, it's raised by 1 knot. Please stop doing that. It's not the thing that you want. Number is not the quality. Coverage itself is not the quality. It might be a small part of the quality, but it's not the full truth. But I have the coverage in the browser library. So what I do, I run the report. I open the report, actually. There's a nice HTML report out of the Python things. And I look this one. I don't look it all the time. I look it when I create something totally new. I look it when I refactor something out of it. And the bad thing about the browser library is that I only have it for the Python side. And I have requested, where's my Kerkko is somewhere over here, when I can have it for the Node side. I really want that for the Node side. Next year? Yes, good, thank you, perhaps. But it gives me information. The red one is that that's not covered by the automated tests, unit or active tests. And then when I look at the report, I can make a decision. Do I want to cover that somewhere else? Do I want to leave it untested? Is it important, not important? There's a data that I can argue about. And I can nicely get that because everything in the browser library, in the Python side, the test and the Python part of the library is actually written in the same programming. So I can easily get that coverage report. In my work, I don't have it. I want it, but there's at least 7 different programming languages in my Windows application. Even though they are compiled as DLL or executables, it's really hard to get them as a coverage. So I don't have it, but if you have it, it's great. And I use it sometimes. I don't look at all times, but it's a really handy thing to have. And this I have it. There's that coverage run -m, but if you're using PyTest or something else, that invoke command is replaced by something else. But I like Python invoke, so it can wrap me stuff around with, so that I don't have to remember all the arguments. I just have invoke, utest, and it runs me. And there's the same thing with the coverage run, and there's the difference. I use the append, so that now the coverage information is not overwritten. It goes to the same internal coverage database, and then I can easily generate a report. And that runs me the acceptance without the Puppet. I didn't get it working with the Puppet. I hope Mikko would be here to explain why it doesn't work with Puppet. I think it's something to do with because Puppet launches multiple processes and something is just lost. But it runs nicely with the robot thing. And you can get the information. You get the report that I showed you earlier. And then, who has Flaky tests? Yeah, I have. If you didn't raise your hand, it's you're not testing hard enough for often enough. And I have to admit, in the browser library, we also have it. And it's driving me crazy. It's really bad. One day, I merged something. Everything was green. Next thing, continuous interrogation happens, or an hour later, it's red. And after that, it's green again. And then it's red again. And that's driving me nuts. And it's actually, if you have a CI system like that, it is actually quite a lot of work. You have to open that, run, you have to download something, you have to open a report, and you have to look. And you have to take a note. What did actually fail? And write down somewhere in your note. And then you go next one, and next one, and next one. Who actually goes through all the failures in your CI system? You're lying. There's one person. I don't. Who looks the first failure? About the rest of them. Who looks the last failure? Yeah, I don't usually, I confess. Who looks something in the middle? Yeah, few people. More than, yeah. Yeah, and that's a very human thing to do. You look the first one, and you assume the rest are the same. I do it all the time. All the people do it. That's just a human thing to do. But what about if you could build a machine for it? And here's a Flaky test analysis tool that we built with. It was built with F-Secure, but then the company name was FitSecure. So let's say FitSecure. Even though the GitHub account still says F-Secure. And it's a nice tool. You save your test results. It eats XUnit reports that you can get out of the report, or any decent testing framework out of it. You save them somewhere. It could be Artifactory, it could be Nexus, or whatever you use to store your test results. For us, it's in a GitHub Artifactory storage. It's free for open source projects. And then you download the results, the XUnit XMLs, and place them in the folder. And then you run the tool. It goes over all the tests, and it sees which test changed its state. And the higher, more often it states, the higher the score will be. If it's more passed down in history, perhaps you fix them, so there's an algorithm that lowers the score. And if it's a recent test runs, the higher it will get. And it's a nice tool. It goes over all the data. And then it shows the results. You have a list. You have a list of test suite and a list of tests, and you have a score. And then you can dictate. Like, if the test fails like 0.01 times, is it worth of the investigation? Perhaps not, but it might be the latest failure that it did look on. And if somebody else did look on the previous failure on that, they might think that the test 3 is the most important things. But actually, both of them are wrong, because test 01 is the most important thing to fix. It's the most flakiest. And this is how it looks in the browser library CI. In the GitHub Actions, there's a failure. It's a nice picture about, we actually use the tool that Pekka did mention. There's that stack trace information you get on console. That's a nice thing tool. You have better information about what is actually failing. And then the first job downloads the artifacts. In that Flaky test direction, there's an example script how you do downloading from the GitHub artifacts storage, or you can just grab the thing that we made for the browser library, and then it downloads the data, puts them in the folder. There's some command line arguments, tell where the files are, how you want to do grouping, and which window size, and stuff like that. The top one, I'm curious that how many tests I actually want to see, and I put it 10. And that first one, test suite 03, wait for element state hidden, not strict, fails about 16% out of the times. And that drives me crazy. But I think René did fix it by, we are thinking to deprecate that. Wait for element states. Did we deprecate that keyword or not? Well, anyway, we should fix it. Think about why it fails so often. And this is easy. The score is important here. It gives you idea what is the most important thing to fix. From the Flaky test point of view, this is not the whole truth. You have other problems. Some tests may fail all the time. Maybe they are more important. But this is something important look also, because if you have those flaky tests that flip around now and then, annoyingly, it kind of demotivates you or hinders trust for the test automation, because if it fails now and then, you don't actually know, is it caused by the flakiness of test or is it caused by the change in your application? And this way you can kind of prioritize part of the work, which you should think about it. But there's more that the tests are telling to you. This is a simplified view of my CI environment. I have a Jenkins that runs my CI. CI actually controls the test execution, and then I get a bunch of Windows VMs from Azure Cloud. And we send the test to them, it's executed, and then it comes back to the Jenkins node or job to execute. And then I have statistics. The first line or the first ID is about it's a Windows application, Windows antivirus client. It sends statistics to a database. Generic stuff. What window did it open? Did it find a virus? Did the user do something, or did the test trigger the UI and something? So it sends that kind of anonymous telemetry that how our client is performing and which kind of environment is running. Is the Windows 10, 11, 62, 32 bits, that kind of stuff. And that already went. So I did use that system. And the second idea is that I meant also the test that executes in the VM. I also sent to the same database, same kind of telemetry information. And if you have an F-Secure client, don't be worried, it's anonymous. We don't send you a username or email, so you're safe in that sense. And I send the test result, pass, failures, or skip, duration of the test, possible exception out of the test, and I sent the test suite name also. Yes, that one. And the cool thing about it, the key thing for me is here, that it goes to the same system, and it has the same ID. I can tie that telemetry that is sent for the client from the database with the test results I do. And every VM that I claim has a unique ID, so every installation of the client has a unique ID, so it's not mixed with other. But that didn't cover us, because sometimes a VM crashes. And I did have a second set of telemetry, and I send it also from the Jenkins job that executes tests in the VM. So it is a kind of like, if the Windows crashes, there's no telemetry for the VM because it's already gone. It's somewhere in the bye-bye. So that allows me to detect the crashes in the Windows itself. Perhaps we did do a wrong kind of DL that caused a blue screen in the Windows. We should find those tests. And that's it. But it doesn't, downfall of that is that it doesn't have the same ID. So I cannot tie the telemetry sent from the Jenkins job to the telemetry that is sent from the Windows VM itself. But it's pretty neat also. And then on the top of that, there's a visualization service. Mine is a redash. Yours could be anything that you want. It doesn't matter what the visualization service is. The important thing is that you have it. And what you get out of the statistics. For example, you know how many tests you have. Who knows how many tests you actually have? Who knows, are you running all your tests in your environment? Like 10 or something like that. You should know that part. Are you sure? Then you know that if that test isn't run, you can delete it, you can remove it. You can, for example, know how long your test execution lasts. And if there's anomalies in the graph, like the spikes, there was something wrong in my VMs. I had to go and fix something. But you get a trend, you get a feeling how your test is going. Or how many of you know that how many times your tests are being executed in a single day? Yeah, 1/3 about things. My average day looks like there's 150,000 to 300,000 tests executed in a single day. That's my team only in the Windows VMs, and not including unit or integration tests. Bad thing about that if I have that many tests, there's also 1,400 failures. That's a lot number. But if you compare it to the total number, that's less than 1%. It's still pretty good. But I don't want to read 1,400 failures. Nobody does that. That's a lot of failures to read. But you get the sense of feeling that how your test is going. So 1,000 failures, 2,000 failures, yeah, that's pretty good still, even though it's a lot of failures. So you can do this kind of deeper analysis of the statistics. This is a feature, and like every client, there's an integration to some backend. And this is showing 3 tests. It's showing the test duration. If the number is a negative thing, it failed. And it was important. We have a promise for the customer that the feature would work in a certain time. So we started measuring the time. And it tells me that that thing is really hard to assert in a test. That sometimes it may be perhaps too long. How is the trend going? I don't know if I don't have this kind of visualization services. It gives you a nice view of how that feature test is flowing. And because we are developing, we have crashes. And to find out it's a Windows application, there's a crash dump, we can analyze it later, if we find it. Before this statistics analysis things, somebody would randomly click on some of the failures and hope that there would be a crash dump. That didn't work very well. There was a lot of crash dumps that customers did complain. So once we had the statistics, we built a view that every time there's a crash dump, we automatically insert as a last test in the test suite this crash dump analysis, so you don't have to manually add it. And the cool thing about it, it tells that there's this error. It happens from the error text. You can see that it happens in this executable or in that DLL. It gives you a nice feeling that is it always the same crash dump? It may happen in different kind of tests. Is it repeating often? If it happens once in a week, I don't care. Sunspots, whatever. 10 times in a day, I care. 5 times a day, I care. So what I do, the red box in the middle shows me that I made the telemetry also the central link. It links to the Jenkins job that they execute that test. So I can go and fetch it, I can put it in the analyze job, and I can show it to the developer. Hi, this happened 10 times in a day. Please go and look it. And at some point he will come and look it. But if you say it happened 100 times in a day, could you look it right now? It's making everything red. That there's a priority on it when you can put a quantity number on it. And there's a different kind of views that you can build. For example, if you look the most failed test cases between a day, it gives you that, it gives you a feeling that what has happened during the day. You can also look by the hour. So numbers are lower, but it tells you you have this kind of different kind of priority things that you don't have to dig out data out of your CI systems. And it's really cool. If it fails many often times, I need to investigate. Or somebody in our team needs to investigate. What's the wrong? How did you fix it? Is it a test fault? Is it an environment fault? Is it a product fault? But at least now you have a feeling how that testing is flowing on. How is your daily testing going on? And what more you can do with the statistics? This is actually one of my favorite pictures. This is a test of one of our features. And again, it's a duration. And in October, before the October, we were doing nothing for the feature. It was static, no changes, nothing. There were a few spikes, but yeah, pretty random, don't care. And then after the October 3rd, we made changes for the feature. We updated SDKs and a few other stuff. And when it's on that 60-minute gap or top, we fail automatically test. And then, but it's fine. That's also information. It's not yet ready. It passes sometimes, but not always. So there's stuff to do. And after the October 17th, everything went fine. It returns always passing. And then we gave it to our manual testing. And she came, and I have to end Trish. She's the most important person in our team. She finds all the good stuff. Test automation is just a safety net. And she came back to our team and said, you know, it feels slower. And we were like, it's a VM, you never know about it. So, but I had this idea, we have an automated test for that feature. Let's plot this graph. And before the October 13th, average duration is 3 to 5 minutes. After the change, 5 to 10 minutes. That's 2 to 3 times more. Now we have a number which you can debate on. Is it good or bad? Should we do something about it? Does it affect the customer? Is it okay that it's 2 to 3 times slower now? And we did investigate it, and I think we came to a conclusion that because there's so much changes, it will do more stuff, so that's fine. But now we know. If customer complains, we can tell, yes, it is slower, 2 to 3 times. Give it more time. And this is my other favorite graph. It is really hard to read, but it's not out of that visualization system. I had a problem when I looked in my CI system that there was a test that was randomly failing, and when I looked at the data from the CI, it looked like it's operating system-specific problem. And I plotted this graph, I extracted data in the CSV, I used pandas and zpoint to visualize data. So each of the graph is from an operating system, individual operating system. Blue is passing, orange is failing, and oh boy, I was wrong. It's all over the operating systems. So I went to the developers and explained that this is happening, it's failing quite often, it's all over the operating system, what we can do. Here are some logs that you can read. And they came with the idea that it's a Windows operating system-specific problem. That at some point, Windows just randomly decides to compile .NET DLLs, and that's what's making our test unstable. So could you go and fix the VMs? So I went and talked with the person who makes the VMs, and he said, yes, I can make that thing go away. And then let's put it on 2 operating systems, and here's the result in those rectangles. And then he asked the important, did it help? Do I have to do it for the other operating systems? And I plotted the data. Great results. You reduce the test execution times like 10 to 5 minutes. Really good results. And perhaps there's less failures, but it's not totally fixed. So I went back to the development team. So we changed that DLL compiling thing. It's not doing that anymore, but there's still more fixes to do because it still fails quite often. Here's some new logs, go and investigate. And we did repeat the cycle all over again. And we did end up in the cycle that it fails a few times a week. I don't anymore care. But at least I know that it is not anymore that stable. That was horrible. It took us a long time to walk that journey, but it was nice to have a data that can tell you that, did the change help? Yes. In which way? Did it make better, worse? What do you want to ask? And this is a combination with the data that comes out of the client and out of my test automation, and I have combined them in that Seaborn library. And it's a really cool. Sometimes, most of the time of the day, I feel more like a data scientist and not as a tester because, well, that is data science. But it's really good to have that data because you can ask different kind of questions out of the data that you don't even realize when you start sending the data. But it's a really powerful tool to have around, and I have a lot of different kind of visualizers for different kind of problems or different kind of things that I want to follow. And it has really helped to improve our quality in many different ways. For example, the crash time problem never happens anymore in the customer. So that was my talk about the data. And remember one thing about the data, that the data is not the oil, data is the uranium. So that if you leak it, it will stay forever in the internet, so be careful. Think about where you put it.
Thank you, Tatu.
Thank you.
So given the title of your talk, you're basically a test whisperer, like a horse whisperer. You try.
Yeah, something like that.
You can change your personal title at the workplace. We have plenty of questions, so let's go through them. Should Flaky tests continue to be a part of your regression test suite execution, or should they be tagged and executed separately? Best practices or guidelines to follow here?
It's so project dependent. I tend to use in my company, and in the browser library, I use the brute force method, always run everything. That's why you have always fresh results. But I understand it is not always possible.
How much time do you consume to find the root cause analysis of test failures?
Depends. Like if it's like that crashed up thing, that takes like a few minutes to download and run the analyze job, and then I show it for the developer because that's easy to spot. But then there are these like different timing issues that code accept to have an ABC, but then CBA happened and it blah, and that's really hard. It taken half an hour, whatever. It really depends.
I think the next question is more for the audience here. Please clap if this applies to you. Who doesn't have flaky tests? You're lying. Tatu, how is your team triaging those 1,400 plus failures? How do you go through those failures?
We don't. We use that kind of like a visualizations that I did show you. It doesn't go back, perhaps in the next time. Anyway, I look, if I want to see how it's working right now, I have a radiator, which is in the Jenkins stuff. And if I want to see how it works, I look the radiator, how is it right now? But if I want to do more analysis, I look the visualizations. I look visualization different times a day. For example, those trends, I look perhaps in the morning or in the evening, depending on how I work. And if there's a failure like that, if I looked at how many tests are passed in the last hour, and it's a high number, then I look that number more frequently during the day. I don't anymore do deeper analysis from the Jenkins or the CI systems.
Yes. Any ideas how would one make debugging failing CI tests easier or more informative?
If you happen to know, please tell me also. But there is some good practices. We have developed some good practices, for example, because we are a Windows application. If a test fails, we have this data collection part inbuilt our testing. We grab all the application logs, we grab everything that we get from the operations, and we pack it as a chip. We put same place the test execution logs, and then you can easily, and we create this kind of package out of each test suite, and then you can download it from the Jenkins. And we have built tools that can analyze, like put in a time order those logs, you can filter and do other stuff. So we have put a lot of effort in the testability world and analyzing that stuff, because it also helps we get the same package out of when there's a real life project in the customer, we ask that package and we analyze it with the same tooling.
Thanks. That's our time. Thank you, Tatu Aalto. It was a pleasure.
Thank you.
One small housekeeping note, please use the questions feature only for questions for the speakers. If you have a question for the community, please use the chat feature or maybe take a coffee and talk with the other people in the room. Next up, we have lunch break, so lunch is served out there. We'll start again here at 2 o'clock. Thank you.